Hi everyone, this is Miss Afric here, and today we're going to start talking about solving equations. So today we're focused on solving rational equations. That means equations with rational exponents. We're also going to identify whether there should be one or two solutions, and check for extraneous solutions. Alright, so let's get started. Now before we begin with the rational exponents, let's take a look at some stuff we did last semester with just normal exponents. So for number 1 it says solve x squared equals 9. So remember, all that's really saying is what number, if I square it, equals 9. And we remember how to solve this. If we were to do it algebraically, we would take the square root of both sides. That's how we get rid of an exponent, right? But if we just think about this logically, what number, if I square it, will give me 9? Well, I know that 3 squared is equal to 9. So there's an answer. And that's the easier answer to come up with, but we always forget about the second possible answer. And that second possible answer is negative 3. Right? Because if I take a negative 3 and I square it, that's like saying negative 3 times negative 3. And negative times a negative equals a positive. So that would work too. Alright, so what that should tell you is when you have to take the even root, because we were going to take a square root here and 2 is even. Alright, when we have to take the even root of something, we end up with two different possibilities, positive and negative. Well, let's see if it works also when we have to take an odd root. So for number 2, we have solve x to the third equals 27. So once again, if I were to solve this normally, I would take the third root of both sides, because that's how we get rid of an exponent. Or if we think about it just logically, what number raised to the third power would give me 27? Well, that would be 3 also, right? Because 3 to the third power is 27. But now here's my question to you. Would x equals negative 3 be an answer? Let's find out. So if I took negative 3 and raised it to the third power, that would be negative 3 times negative 3 times negative 3. And whenever we're multiplying more than two things, we just do 2 at a time. So negative 3 times negative 3 is 9. And then by another negative 3. So 9 times negative 3, that's negative 27. Does that match up? Not exactly. Right? 27 is not the same thing as negative 27. So when we take the odd root of an expression, we're actually only going to have the one solution. Right? So that's kind of a big important point when we're doing rational exponent equations. Alright, when we take the even root of something, we're going to have two solutions, positive or negative, plus or minus. Alright, and sometimes we can get extraneous solutions, so we're always going to check our answers, and you'll see we'll do that every time today. Alright, but when we take an odd root, we only have one solution. And if we're taking the odd root of a positive number, it'll be positive. If we take the odd root of a negative number, it'll be negative. Alright, so just the one solution. But wait, it's not quite that easy, because we're not just going to be working with regular exponents, we're working with exponents that are fractions. Alright, so we have to make sure we remember which part of the fraction is the root. So remember, when you see something like 9 to the 3 halves, where there's an exponent that's a fraction, the top number is our exponent, and the bottom number is our root. So in other words, the root is in the denominator. Alright, so when we check to see if we're doing an even root, we're going to look for what ends up being the denominator of our exponent. So let's try number 1. Alright, number 1 says solve, check for extraneous solutions. X to the 2/3 plus 9 equals 34. So remember, anytime we're solving any kind of equation, we always do reverse PEMDAS. So maybe make a note of that so you remember what order to go in. Alright, that means we get rid of addition and subtraction first, and then we get rid of multiplication, division, then exponents, then parentheses. So we're going in reverse PEMDAS order. So for number 1, I see this plus 9, and I know that that's the first thing that's got to go. So I'm going to subtract 9 from both sides. Alright, we end up with x to the 2/3 equals 34 minus 9, which is 25. And here's the new part. Alright, so now the only thing left to do is get rid of this exponent. And technically, this exponent has a root, that's 3, and an exponent of 2. So we could get rid of each one individually, but that takes up more time. We're always trying to be more efficient when we're doing math. Alright, so instead, the easiest way to get rid of that entire exponent at once is, we'll just think about how we normally get rid of fractions. We use the reciprocal, right? So we're going to do the same thing here. To get rid of an exponent that's a fraction, we're going to raise both sides to the reciprocal of that fraction. Alright, so the reciprocal of 2/3 is 3/2, so I turn 3/2 into the exponent for both sides of my equation. And what ends up happening is 2/3 times 3/2 is just 1. So we end up with just x to the first, which is just x. And that's what we want, right? We want to just have x, get rid of anything around it. Alright, now on the other side it's a little trickier. Not only do we have to evaluate this expression, but we also have to figure out if we have an even root, because if it's an even root, we need our plus or minus. So remember, the root is in the denominator. So in this case, the denominator is 2. That means we do have an even root. And anytime you have an even root, you need that plus or minus when you simplify. So this is going to be plus or minus 25 to the 3/2. And then we would just have to simplify that. Alright, so think back to the last chapter when we did this. 25 is the same thing as 5 squared. 5 squared to the 3/2, we just multiply these. And you can use your calculator, obviously. Don't be afraid to do that. 2 times 3/2 will give me 3. So I end up with plus or minus 5 to the 3rd, which, if you use your calculator, is plus or minus 125. Alright, and those are my two answers. Now, don't forget, we did mention something earlier about possible extraneous solutions. So we're always going to make sure we check for those extraneous solutions. And most of that check can be done on our calculator. So take your calculators out if they're not already. Alright, so in order to check these answers on my calculator, I'm just going to plug both of these answers back into my original equation. So remember, I do have two answers here. I have the positive 125 and I have the negative 125. And when I plug numbers back into an equation, I always use parentheses. So I'll have parentheses 125, I'll do the positive one first, caret. Now be careful here, some of you need parentheses around the exponent, so I'll put it in just in case. Alright, 125 to the 2/3 plus 9. Oops. Be careful. Let's make sure we're typing this in right. There we go. Plus 9. And remember, if this is an answer, then this should equal 34. And it does. So our first one works. I'll type the exact same thing in, but now a negative 125. Once again, I'm going to use parentheses around my exponent, just in case. And then plus 9. And once again, we get 34. So that's how we know both of these work. I put a little check mark next to it so I know that I did check it, and we're good on that one. Alright, let's try some more. So number 2. Number 2, we have 2x plus 1 to the 1/3 equals 5. So again, remember, reverse PEMDAS. So everything that I see in there is inside parentheses, and that's the last thing we do. So that means the exponent is going to be the first thing I get rid of. So to get rid of that exponent, I'm going to raise both sides to the reciprocal. So a 1/3 exponent, the reciprocal of that would be a 3/1 exponent. Alright, so on the left side again, 1/3 times 3/1 is just 1, so we're left with just the 2x plus 1 part. But on the other side, before I continue, I want to check to make sure what my root is. Because again, remember, if it's even, I need to plus or minus. Well, my root here, the bottom, is 1. 1 is an odd number. So since it's an odd root, I do not need the plus or minus. Alright, so I just have 5 to the 3/1. Remember, 3/1 is just 3. So 5 to the 3rd, that just ends up being 125. And now we just have a linear equation to solve. So I would subtract 1 and get 2x equals 124. And then divide both sides by 2. Alright, so we end up with x equals 62 as our answer. Just one answer because it was just an odd root. Alright, and then I'm going to make sure that I check. There's just one number to check, x equals 62. So in my calculator, we've got, now be careful here because it can be a little tricky. We have the original parentheses, 2, and then whenever I plug something in, I use parentheses. So 2 times 62. close those parentheses, plus 1, close that parenthesis, and then to the 1/3. And this should equal 5 if we did it right. Awesome. Not just if we did it right, actually. If it's not an answer, you could have done everything right and still not get it, right? But in this case, we at least know that, yes, x equals 62 is an answer, so we're good. All right, just a couple more to check out. Number 3. So number 3, we have a few things happening. All right, let's make sure we know the order we're doing. Get rid of addition or subtraction first, so that's this plus 5 here. All right, and it's equal to now 243. And then I get rid of multiplication or division, so divide both sides by 3. So remember, reverse PEMDAS if you're ever not sure what order to do things in, backwards from PEMDAS. All right, and I'm going to use my calculator to help me out here. 81. All right, so once your exponent has nothing outside of it, that's how you know it's time to get rid of the exponent. So again, we raise both sides to the reciprocal exponent. Awesome. So on this left side here, we're just left with x plus 1. But on the right side, we got to check to see if we have an even or odd root. Remember, root's in the denominator. That's even because it's 4. And an even root means plus or minus. So this will be plus or minus 81 to the 3/4. Now once again, I'm going to simplify this just using what I did in the last unit. So 81, if I break it down, 9 times 9, 3 times 3, 3 times 3. So that ends up being 3 to the 4th. Right? So that's 3 to the 4th to the 3/4. Multiply those exponents out. I have x plus 1 equals plus or minus 3 to the 3rd, which gives me x plus 1 equals plus or minus 27. Now, I'm not done yet, but there's a little trick here that you have to remember. Whenever you have two separate answers and there's more work to be done, we do have to split it up. So I'm going to split this up. X plus 1 equals a positive 27, and x plus 1 equals a negative 27, and then finish solving from there. So we get x equals 26 and x equals negative 28 as my two answers. Remember, even root means you'll have those two different answers. Alright, and now I'm going to check these. And remember, two separate answers, so check each one of them. So we've got 3 parentheses, 26, plus 1, close the parentheses, caret to the 4/3, move over, plus 5. And this should equal 248 if we did it right. Awesome. So this one checks out. So now I'll do the same thing, but with a negative 28. And actually, there's this little trick you can learn on your calculator. Since I want almost this identical expression again, if you press second and then enter, it'll show the exact same thing you just typed. And then you can just go in and edit the part that you're trying to fix. So for example, I don't want this to say 26. I want it to say negative 28. So I'm going to insert a negative and then change that to a 28. Now you can always retype it again. I just like those shortcuts. Alright, and that one works also. So both those end up being our answers. Alright, one last one, number 4. 7x to the 5th plus 5 equals 229. So get rid of addition or subtraction first. Oops. There we go. So 7x to the 5th ends up equaling 224. And then again, we get rid of multiplication next. So x to the 5th equals, let's use our calculator, 224 divided by 7, 32. Now, this is not a fraction as our exponent, but remember, we can always rewrite that as 5 over 1. So if I want to raise it to the reciprocal, it would just end up being 1 over 5. Okay, so we would end up with just x equals 32 to the 1/5. And here's what I want you to do, just to make sure you're getting good at this simplifying part. I want you to try and finish this one on your own, because there's not too much left to do. Just simplify. Alright? So go ahead and do that part. We'll check our answers in class. If you're confused on anything, just go back and rewatch and write down any questions you have. Alright, talk to you later.